Right guys, as promised, here are the solutions to the rest of this paper that we started today. Question 1, and I will fly through this pretty quickly, so do make sure you're pausing it and replaying anything that you need to. Also email me and I can talk you through anything else, guys, if you got any questions. So Joules buys a washing machine, 20% VAT is added to the price of the washing machine. That means we're now at 120%. Joules then has to pay a total of £600. So 120% is equal to 600. What is the price of the washing machine with no VAT added on? So we need to get rid of that 20%. It's not 20% of the 600 because that's 20. That'll be 20% of 120%. We don't want that. We're going to have to go back to 100%. What we'll do is find 1% first. So divide both sides by 100. And once we've done that, we want to find 100%, which is the original amount. So we'll be timesing by 100 afterwards. So we've got 600 divided by 120 is 5. Make sure that you're showing that you've divided by 120 here, and that is your workings. So 1% is £5. Now multiply that by 100. £500 was your original amount. Think about it. If you're adding on 20%, that's 1/5. 1/5 of 100 is £100. Sorry, 500 is £100, and that'll take you back up to the 600. So it does look right. Solve simultaneous equation. Right, as soon as I'm seeing this, I'm thinking we've got to cancel either the x's or the y's. Either one is absolutely fine. I'm going to cancel the y's because I've got a positive and negative, and it's very easy to change this y into a 3y. So I'll times the top by 3. We've got 12x plus 3y equals 75. And underneath we've got x minus 3y is equal to 16. So all I need to do now is add the two equations together. So 13x, these cancel each other out because one's a positive, the other one's a negative when you add them together. And adding these two together gives me 80, 91. Divide both sides by 13. So x is equal to 7. If you wish to cancel the x's up here, that's absolutely fine. You'd just be doing something slightly different. Probably multiply that by a -4. Okay. We've got the x value. Substitute back in to find the y value. Let's use the second equation this time. So x minus 3y equals 16. Replace the x with a 7. Minus 7 from both sides. So minus 3y is equal to 9. Divide both sides by minus 3 because it's a negative 3 here. And that leaves us with y is equal to minus 3. And as I've said previously on many occasions actually with these ones, always follow through to the end. Even if you think you're wrong, you can't understand where you've gone wrong here, do the substitution, follow it through, and you will pick up the bulk of the marks. Right, for number 3. On a school trip, the ratio of the number of teachers to the number of students is 1 to 15. The ratio of the number of male students to the number of female students is 7 to 5. Work out what percentage of all the people on the trip are female students. So another way of writing these is the students we're focused on. So a school trip, teachers to students. So in terms of this one up here, 15 out of 16 people on the trip are students. The ratio of the number of male students to the number of female students, so the 5 is the female. So the fraction of female students is 5 out of a total of 12. And remember, it's female students, so the 15, 16 was the students, the female students, 5/12 of this. So we're looking for 5/12 of 15 out of 16. Of in maths means multiplication, so it's 5/12 multiplied by 15 over 16. 5 times 15 is 75. And 12 times 16 is 192. Work out the percentage. So it's the percentage we need. So it's top, the numerator, divided by the denominator. That's what my calculator has given me. So it's simplified it, so change it, and there's your decimal. Make sure you write down all the digits. 39090625. Change into a percentage, multiply by 100. So it is 39.0625%. Make sure you've got all those digits down. Give your answer to the nearest whole number. Sorry. So underline 9, circle a 0, so it's 39%. Number 4. So we've got Oliver records the distance from London to each of 8 cities in the USA. There are 8 cities scattered across this graph. He also records the time taken to fly from London to each of these cities. The scatter graph shows this information. So on the vertical axis we've got distance in miles, we've got time taken in minutes on the x-axis. By drawing a line of best fit, find an estimate for the time taken to fly from London to Chicago. This one tells us to draw the line of best fit. Normally it doesn't. Even if it doesn't, make sure you are drawing the line of best fit. So it was 8 cities, 8 x's. So I want is 4 x's on either side of this line. And that is roughly not too bad. So there is my line of best fit. It doesn't have to be perfect. Again, it's an estimate. By drawing a line of best fit, find an estimate for the time taken to fly from London to Chicago. So it's 4,000 miles. So we're looking for miles is up here on your y-axis. Find 4,000. Come across and down. So our number here, and we do need to be precise about it. That would be 6, 7, 8, 9, 490. 490 minutes. Make sure you've got these working lines in as well, okay? Show how you're getting that 490. And remember, that is just an estimate. So even if on your one, because your line will be different, if you're getting 480, 495, anything around that range, that's absolutely fine. Why is your answer to part 1 only an estimate? Because the line of best fit is only an estimate, and that is all it is. So it's only an estimate. Calculate the gradient of the line of best fit. Right, a couple of different ways you could do this. Could use your y2 minus y1 over x2 minus x1 by finding 2 random points in here, or we can try and draw a triangle underneath it. The triangle looks messy, so I'm going to stay away from the triangle, just because I can't see a nice easy triangle to draw there. So let's try and get some points. I've said earlier, so 1 point would be the 4,000, sorry, the 490 and the 4,000. That can be one of my points. The second point, take it from wherever you want. Let's go with the 500. So at 500, in terms of the miles, it's going to be 4,100. I'll come up to it here. Again, yours will be slightly different because of the line of best fit, alright? So I'm going to use this point here. And it was 500 and 4,100. So it's y2, take away y1, that'll give you a difference of 100. So I'm going straight to my solutions now, okay? And then it's x2, which is the 500, take away the x1, so 500 take away 490 is 10. So my gradient is 100 divided by 10, which is 10, sorry. And that's not exact. So if you got probably anything in the 9s, maybe 11, anything between 9 and 11, that's absolutely fine. But do please make sure you're showing your workings, okay? Those 2 points, show that it's 100 over 10. You're doing your division to get that answer. Give an interpretation of the gradient of your line of best fit. So not only is it positive, but it wants to be more specific about this. What's it telling us? So it is telling us that for every 10 minutes, so an increase of 10 minutes, an increase of 10 minutes results in an increase of 100 miles. So as the time increases, the distance increases by 10 times as much. So if I increase by a minute, that goes up by 10 miles. If it's 100 minutes, it's 1,000 miles, and so on. But be specific, refer to what is on your x and what's on your y-axis, the minutes and the miles. Right, set theory hasn't come up yet actually, so do make sure you're revising it and are very familiar with especially these two guys. So there's your information. We want A union B. So that's all of A and all of B together, everything in it. So in A we've got 15, 12 and 18. In B we've also got the 12 and 18, which we've already counted, but we've got 10, 14 and 16 also. And that's it. So you've listed everything that's in both of those. Next one is A intersection B. A intersection B is the bit in the middle. That's all it is. So that is 12 and 18. Make sure you got a comma in between them, okay? One of the 9 numbers in the diagram is chosen at random. Find the probability that the numbers in the set it's the cardinal set of A, okay? So it's everything other than A. Think of it that way. Everything except A. It's probability, so we're going to write this as a fraction. First thing we'll do is what's it out of? Well, it's out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 possible numbers we can pick from here. But we're looking for the probability that's not in A. Well, if it's not in A, then it could be 11, 13, 17, 19. So that's 4. It could be the 14, the 16, the 10. So that's a total of 7 numbers that are not in A. So it's 7 out of 10. We don't include the 12 and 18. They are in B, but they're also in A. And we want to exclude that. Nothing in A. So it's 7 over 10. Or you can write it as 70%. or 0.7, whatever way you wish. Either one will do. Question 6. So in terms of question 6, we've got the heights of 80 children. Here are the intervals, and we've got the frequency for each of them. Find the class interval that contains the median, so the middle. Well, if it's the middle, if it's the 40th child, because there's 80 in total. So looking at it, there's the first 15 children, so it's not in there. 15 plus 24 is 39, so it's not in there. Plus another 22, so it's got to be in this interval here. Because 39 plus the 22 is 50, 61, so the 40th is somewhere in here. It's in this 22, and that's all it is. It was the class interval, so make sure you put down that exact interval. H is less than or equal to 170 or greater than 160. Draw the frequency polygon for the information in the table. Right, it's a polygon, so we're going to need straight lines. But also with these polygons, what we want is midpoints. We want to draw from the midpoint. So our coordinates will be, midpoint here is 1, I'll put it over on this side, 135, 145, 155, 165, and 175. So plotting these, first one was 135 and 4. That's 1, 2, 3, 4. It's gone up in ones each time. So here's the first one. That's 134 and up to 4. Sorry, 135. The second one was 145 and 11. So 145 is, I have to use a ruler on this. 1, 2, 3, 4, 5. So it's there, and I'm coming up to 11, which is here. So mark it with an X, and we'll eventually be joining up these X's. 155 and 24 is the next one, which is here. 1, 2, 3, 4. Mark it with an X. Okay. 165 and 22. 1, 2, 3, 4, 5. And we'll come up to 22. Lastly, thankfully, 175 and 19. It's tough in your eyes. Lastly, remember it's a polygon, so we want to join them up using straight line. Do not do it freehand. Make sure that you're showing that it is straight lines. So that it looks something like that. Right, number 7. The diagram shows the position of two churches, A and B. So here's A, that X right here, and church B is over here. Church C is on a bearing of 130 degrees from church A. When it comes to bearings, we want to start at 0 from north. You'll see what I mean by that in a second. You want to measure it clockwise. and they've done it here because they had to. But make sure it's 3 digits you use. So e.g. 90 degrees is wrong. What you should have is 090 degrees if you're ever talking about bearings. Right, so we want 130 degrees from A, and that's going to be our C. So with your protractor, set it up. You want center protractor on this X. This line here needs to be on top of your north facing line, like I have here. And you want 0 at the top, because 0 is from where you're going to start. You're going to start from north, which should be 0 degrees. As I said earlier, make sure it's clockwise. So we're going around, and it's the outside numbers I'm using, because it's 0, 10, 20, 30, etc. all the way around to 130 degrees. And there it is. Before you finish with that, it's a straight line you want, because it could be anywhere along this point that church C is. So here's my straight edge, good and long, like so. So that's telling us that church C is somewhere on top of this line, because that angle there is 130 degrees. Church C is on a bearing of 245 from B, so set it up the exact same way. Center point of protractor is on that point. Straight line is on top of your line. North is at 0 degrees. We're measuring it around 245. It's against the outside, so the small number is getting bigger. Going right around to 245, which is there. So again, join it up with a straight edge. Don't swear, miss, I'm recording, alright? No swearing, I'm recording. It's for year 11s. Apologies guys, that's Miss Banner getting locked out. No worries, miss. Right, so join these up with a straight edge. There you go. You can continue this on if you wish, but actually all I'm looking for is where they intersect. Sorry, I should label this 245 degrees. Again, it was clockwise we went on that one. So that's where it is. Actually, I should read the question really, but I'm presuming this is all it's looking for. And the space above, draw an accurate diagram to show the position of church C. We've done our accurate diagrams. Mark the position of church C with an X. So make it good and clear. That is where church C is, where those two lines intersected. On label it C, which we've done. Okay. Make sure you're not rubbing out any of this. That's all your workings. Okay, you get marks for that. Question 8. Diagram shows the square. It has sides 8 centimeters inside a circle. Vertices of the square lie on the circle, as you can see. Work out the total area of the 4 shaded segments. Give your answer correct to 3 significant figures. So that's important towards the end. Right, it's total area. We've got a circle in there, so I'm definitely going to need pi r squared. You've got, of course, that square. So if I can get the area of the circle, subtract the area of the square, then I'll have the area of the shaded bit and I'm finished pretty much. So what I can do first actually is pick up some easy marks. Total area of square, that would be simply 8 centimeters by 8 centimeters, so it's 64 centimeters squared. Now for the area of the circle. You'll notice with the circle we've got a problem. We need the radius to calculate, but we're not given it. We know that this side here is 8 centimeters, but that's not the radius. Here's your radius, O to C or O to B. what we can do, and I always look for it in these types of questions, can you draw a right angle triangle? So we've got OB, we've got OC, there's your triangle, BCO. We know that BC is 8 centimeters, that's given up here. We don't know what OB is or OC is, but what we do know is they are both radiuses. So let's call this R, and let's call this R. Whatever one of them is, the other one's going to be exactly the same, because as I said, they are both radius of the same circle. We can use Pythagoras on this. We can say h squared is equal to O squared plus A squared. So clearly 8 is our h. O and A doesn't matter. So 8 squared is equal to R squared, which is what I'm saying O is. A is also R, so plus R squared. 64 is equal to 2 R squared, and I'll pause at that. You didn't have to call them R, you could call them both X's, but the key thing is they are both the same. So whatever you call one, the other one needs to be exactly the same. Right, we want to just find R on its own, so divide both sides by 2. 32 is equal to R squared. Square root both sides. So square root of 32 is equal to the radius R. I would leave it as it is right now. You should be able to see that. Root 32 is going to be some messy decimal. It's not a square number, so let's leave it as that for now. So that is the radius. That was the key bit really, getting that, because now we can use that to find total area of circle is pi r squared, which is pi times root 32 squared. Pi multiplied by root 32 squared will just be will just be 32, I should say. And lastly, so this is where our calculations need to come in. 32 multiplied by pi will give us 32 pi, which is useless, so change, and there you go. Make sure you write down all the digits. 5309649. That would be centimeters squared. As I said previously, it's just a shaded bit we want. So the whole circle is 100 point something. Take away the 64, that'll give us just a shaded bit. So minus 100, and it's still in the calculator. So the shaded area equals, sorry, why did I take away 100? That was stupid. I should have taken away 64. Ugh. So add this 100 back on. What's that? Let's take away the 64, and that's what it should be, the 36. 36.530964991, and that is centimeters squared. The last mark is for giving a correct to 3 significant figures. Third significant figure is 5. Circle the 3. 3 won't do anything to the 5. So your answer is 36.5 centimeters squared. So I think one of the key things, at least from that, is if you can find the right angle triangle in a shape, then take that out. There's a good chance you might be able to use Pythagoras or SOHCAHTOA. That'll lead you to solving the whole problem. Right, question 9, expanding triple brackets. Nothing confusing about this. We'll expand 2 brackets, whatever answer we get, we'll multiply all of that by the third bracket. It'll be messy, but the maths behind it is pretty straightforward once you take your time at it. Right, let's do these first two brackets. So 4x minus 5 multiplied by 4x plus 5. 4x times 4x is 16x squared. 4x times plus 5 is plus 20x. Make sure you're doing your parrot signs as well so you don't forget anything. Minus 5 times 4x is minus 20. Is that right? Yeah, it is. Minus 20x. Minus 5 times plus 5 is minus 25. Tidy it up as much as you can. They'll cancel each other out, so you're left with 16x squared minus 25. And now that needs to be multiplied by the final bracket, 3x minus 7. I should say actually, it won't always be the case that you are able to cancel these. Okay, we're lucky enough here that this was difference of two squares. It's not unusual to have 3 terms in this bracket. Okay, so do expect to have to do a little bit more multiplication. Luckily this one, there's just 2 terms left. 16x squared times 3x squared would be 48 x cubed. 16x squared times the minus 7. We'll do this on the calculator to make sure. So 16 times 7 is equal to 112. So that's minus 112 x squared. Now we've got minus 25 times 3x is minus 75x. Minus 25 times minus 7 is going to be a positive. 25 multiplied by 7 is 175. Look to simplify wherever you can. There's nothing that can be added together there. No. So that is my final answer. Can't do any more with it. That's it. Right. Next we need to prove that these two added together will give us this fraction. It is important to remember we want to find 2 over 3 at the end. So there might come a point where it looks a bit confusing, but what we want to get to is the 2 over 3, okay? It's in fractions, so eventually I'll want to change these into fractions. But because they're recurring, and that will come up with recurring decimals as well, change them into fractions, what we'll do is this. X is equal to 0.30, and that's 0 and that 3 are recurring. What I want to do is get all the digits to one side. So I want to get the 3 to one side, but I want to get that recurring 0 as well to the other side. So to do that, you'd have to move the decimal point twice. So if I multiply both of these by 100, I'll end up with 100x is equal to 30.30. That 30 is recurring. But I don't want this recurring bit. So if I could take x away, minus x, and x we're saying is 0.30, and again that 30 is recurring. So subtracting both of these, we end up with 99 x's is equal to, and this is what we wanted. We don't want the recurring bit. They subtract from each other, so all you end up with is that 30. Now we can say that if we divide both sides by 99, x is equal to 30 over 99. And at the moment I'm going to leave it as it is for now. I might simplify it later on. But I've got it as a fraction, which is what I wanted. No more recurring decimals, which is messy. We're going to do exactly the same for the second recurring decimal. So x is equal to 0.36, and they're both recurring. It just so happens, it's a coincidence, you've got 2 digits to recur this time, same as previously. So I need to get both those over, so I'll have to multiply by 100 both times. 100x is equal to 36.36, and 36 is recurring. Again, we don't want that recurring, so we could take this one away from it. So minus x and minusing the 0.36 recurring. Now we've got 99x's is equal to 36. Divide both sides by 99. So x in this case is equal to 36 over 99. I've replaced these recurring decimals with nice simple fractions. If we rewrite what we originally had, I'll do it up here actually. So the 0.30 recurring is now 30 over 99, and we're adding to that the 0.36 recurring, which is going to be 36 over 99, and that should equal 2 over 3. That's what we want to show. If we add these together, we've got the same denominator, so we can add them straight away. 66 over 99 is equal to 2 over 3. I'm not so sure about that yet, but maybe you can notice that 33 divides into both of them. So if I divide by 33, divide the bottom by 33, we end up with 2 over 3 is equal to 2 over 3. And that's it. That's what we wanted, to get that 2 over 3. On this one over here, it's about multiplying by whatever you need to, okay? If I had an extra digit here that's recurring, I'd multiply it by 1,000, because I need to get 3 digits onto the other side of that decimal point. So whatever it is you need to multiply by, now to get all the digits onto one side, then that is what you need to do. Right, number 11. So Misha mixes 40 milliliters of orange squash with 250 milliliters of carbonated water. So here's your squash, and there's your carbonated water. And that will make a sparkling orange drink. So there's a third drink, or whatever you want to call it, involved in that. The density of the orange squash, so if it's density we're talking about, we want density, mass and volume. The density of the orange squash is this. Right, what we're going into now is a lot more detail, so what I'm going to do is start laying out my answer. Orange squash, and if I do a density, mass, volume triangle, okay, I'm going to do a bit bigger than that actually. We know that for the orange squash we've got volume is 40. There's your volume. Got 40 milliliters. I'll keep that units actually. Density we know is 1.04, and that's grams per milliliter. The mass we don't know, but we do know it's got to be in grams. Okay. And actually, let's go ahead and find that now, okay? And it'll probably pick us up a mark. So the mass for the orange squash is going to be density multiplied by volume. So 1.04 multiplied by 40 is equal to 41.6 grams. So that is our mass, and that was 1.04 multiplied by 40. Make sure you've got the calculation in, okay? And that equals mass. I'm probably going to end up doing the same for carbonated water and sparkling water. So Let's do water here, so carbonated water. Fill in what we know. We know volume is 250 milliliters. We now know that the density for the water, oh sorry, that's sparkling water, so we don't know that yet actually. Let's leave that. Work out the density of the sparkling orange water. Right, let's go for the orange drink. Sorry, this is our sparkling water. So our sparkling water, I don't know why they've used different things for it, to make sparkling orange drink. Okay, now your sparkling water is the same as the carbonated water. Okay, so carbonated or sparkling. Don't know why they've used two different words for that. So you've got your water here. So the sparkling water or carbonated water does have a density of 0.97 grams per milliliters. I know that because the two of these combined will make a sparkling orange drink. So the density of that is what we're looking for. Right, let's continue with back here. Let's find the mass. So similar to previously, to find the mass, it's going to be 0.97 multiplied by 250. It's grams in the density, so the mass is going to be grams. 0.97 multiplied by 250 is 242.5 grams. Now in terms of the sparkling orange drink, you've got this in orange squash, you've got the weight of it, or the mass I should say, sorry. You've got the mass of the sparkling water, or carbonated water, whatever you want to call it. When they're combined, they're added together, and it'll give you the mass for the sparkling. So, if we add 41.6 plus the 242.5, we end up with 284.1 grams. That's the mass of our orange, or sparkling orange drink I should say. The volume is going to work in the same way. So 40 milliliters plus another 250 is 290 milliliters. And our last step is pretty straightforward. Find the density of the sparkling drink. Do note that we're going to give our answer to 3 significant figures. So density is mass divided by volume. 284.1 divided by 290. Units, actually it's already given to us here, so we don't need to stress about that. But in our calculator, divided by 290, and our answer is this. So 0.979655172. Always write down all the digits. 3 significant figures. That 0 is not significant because it's out here on its own. First significant figure is the 9, second is 7, and then this 9 is the third, so underline that, circle the 6. 6 makes the 9 go up to a 10, carry the 1. So this is an 8, 9, 0.98, that goes in there, grams per milliliters. It's 3 significant figures, so do make sure you got that 0 in, okay? And that is your answer. 0.980 grams per milliliters. So the layout of that is really important. If you've got more than one material or product, whatever it is, here we had the orange squash, sparkling water, and they combine to make the sparkling orange water. Keep them separate and bring it together a bit like a puzzle, find out what's missing. Number 12, find a set of values for x for which this is greater than x squared. First thing we'll do is, let's go with 12 plus the 4x is equal to x squared. So what I want to do is get everything on one side. So if I bring 12 and 4x over, we now end up with x squared minus 4x minus 12. Don't worry about the signs, we can put those back in at the end. We want to set the values for this. So we're looking for x. We're trying to solve for x basically, which means we're factorizing this. So factor pairs of, we need to split it, sorry. So minus 12. We want factor pairs which multiply to give minus 12 but add to give the minus 4. We go with 6 and 2. We go with a minus 6 and a plus 2. That will work. So x squared minus 6x plus 2x minus 12. And that's all equal to 0 actually. So factorizing it, x minus 6. So this should be x minus 6 on this side. And this would be a positive 2, and that works absolutely fine. So brackets, you have x minus 6, and you have x plus the 2. Put them equal to 0, so x is equal to 6, and x is equal to, sorry, I'll slow down a bit, x plus 2 is equal to 0, so x is equal to minus 2. There was the inequality, which tells us that x lies anywhere in between those in order to solve it or find a solution for it. So think of it as a number line actually. You'd have your 6 here, you'd have your minus 2 down here. The inequality sign is not equal to that value. So if you were to draw it, it would be an empty dot, and it can be everything in between. But we need to write this as an inequality. So x could be less than 6, could be 5, 4, 3, 2, 1, etc. But x needs to be greater than the minus 2. So that is actually your answer. Minus 2 is less than x, which is less than 6. Key thing there is, forget about the inequality sign initially, think about it at the end when you put them back in. That's really common sense. It'll end up being the numbers in between these, because it's got to be greater than the minus 2, which is this way, but it's got to be less than the 6, which is everything in between. Right, 2 more because I'm losing my voice. In lesson we did the 13 one. If you want to, make sure you are revising iteration guides and rearranging it. I did say I would go over that one. I'll have another look at it actually in a minute, but I'm pretty sure that that is a misprint. Right, for number 4. So we got a geometric sequence below. If it's geometric, then something's multiplying each time, as opposed to an arithmetic sequence where you got dino. So either something's been added on each time or taken away. You've got your quadratic sequence, so it's not the same thing every time. That's where you're looking at second difference. But in this one, it's geometric, so you're multiplying by something every time. Right. So on this one, okay, it's about spotting really. What do you change by each time? How are you getting from 2 times root 3 to 6? If I did 2 root 3 and I multiplied it by a root 3, what you end up with then is, I'll do slowly, you end up with 2 root 9. We know what root 9 is. It's 3, so you end up with 2 times 3, which is equal to 6, which is what you've got there. We can double check it with another one. If we did, actually it's pretty obvious when you look at the second one actually. So 6 multiplied by root 3 just simplifies to be 6 root 3, which is what we've got there. So it is multiplying by root 3 every time. That's what your difference is. All we have to do is find the next two terms. So I'll take the last one, which is 18 root 3 multiplied by root 3. So that becomes 18 root 9, which is 18 times 3, which is equal to 54. So that'll be the next term in the sequence, 54. We want the one after that as well, so we'll have to do 54 multiplied by root 3, which is simply 54 root 3. And that's all there is to that one. So recognizing geometric sequence is you're multiplying by something each time. Right, back down to this one. So y is equal to that. P, it's been rounded, corrected two significant figures. So we're looking at upper and lower bounds here, guys, straight away, okay? As soon as it starts mentioning things like corrected two significant figures. Same with Q, R, this time it's one decimal place. Now the lower bound, let's not worry about that. Let's start to work out the bounds for each of these, okay? So let's deal with P first. So P is equal to 15. It's been rounded to two significant figures, so that's telling me that they would have looked at the units column, because that's what the 4 represents. That's your second significant figure, and they would have, depending on what was in here, they would have rounded up or rounded down. So what we're going to do is take this value, which is a unit as I just mentioned, half it, which is 0.5, so we're going to have to add on 0.5 to the 14 and take away 0.5 to the 14. So for P, it could have been 14.5 or it could have been 13.5. Either one of those, rounded to two significant figures, it ends up being 14. I know this one up here, as we've discussed, technically it rounds to 15, but what we say is that it's getting as close as possible to that 14.5 as possible. Technically it's 14.499999 recurring, but the simplest way of showing it is just this, okay? So it's that 14.5. Q is going to behave in the exact same way, because it's two digits, it's two significant figures, so it will be 12. The upper bound is 12.5, the lower is 11.5. Let me just keep them separate actually. And for R, so what's happened with R is it's correct to one decimal place, so you would have had the 3.5, let's say. There's another digit after it, so they would have looked at, that's what you're rounding, look at the second one. So we're looking at halving this one. So it would have been 0.05. So R is 3.5. The upper bound would be add on 0.5. 0.05 I should say. So it's 3.55. Or it could have been 3.45. And you can see either one of those rounded to one decimal place, it comes to 3.5. There are the upper and lower bounds for our three variables. We want to work out the lower bound, so the smallest possible value for y, and then eventually at the end give it correct two significant figures. We want the smallest possible number for y, which means that for the top number we're going to need the smallest possible value on top. So we want to do a really small number divided by as big a number as possible. That'll give you the smallest possible number here. So for y, it's going to be 3 multiplied by, remember, we want the smallest possible value on top. So we want the smallest possible value for p, which would be its lower bound, 13.5. And underneath, we want the biggest possible value. So to get the biggest possible value from a subtraction as so, we want to get the biggest possible value. So what we'll do is take the biggest possible value for q, which is the 12.5. And we want to have the biggest difference underneath, okay? So take the biggest value for q and subtract the smallest value for r, which is the 3.45. So subtract 3.45. If you're unsure about which ones to pick in the exam, experiment with it, okay? So maybe use an upper bound, you mix them up a little bit, see what answer you get, whichever is the most desirable one, i.e. the smallest possible value for y, that's the one you're going to go with. Right, y is equal to, that's going to be 40.5 divided by 9.05. So 40.5 divided by 9.05 is equal to, God damn it, do it again, bloody hell, 40.5 divided by 9.05 is that. So y is equal to 4.475138.122. Let's correct the two significant figures. So second significant figure is the second 4. Circle the 7. So my answer is 4.5. Yeah, two significant figures, that's right. Okay. Right. We did the other ones today. So back to this one. This is a misprint because either way you factorize it, it doesn't come out as what you want. So if I factorize this, so we did this one earlier, x squared is equal to these, which isn't what we want. We don't want an x squared here. We want the x squared down here. If I do it this way, so factorizing out x equal to 7, divide both sides by x squared plus 5x, you end up with x is equal to, which is good, that's what I wanted here, the x on its own, 7 divided by x squared plus 5x. So the x squared is right, but it's not 5x we wanted. It should have been a 5, but that is definitely a misprint. I reckon that should have been a 5x there to make it work. So again, it's watching out for what you want. You want that x squared underneath. You've got an x cubed, so you're going to have to do some factorizing with that initially, okay? So that one there is not right. It was a misprint. There's no other way of doing it. It should have been a 5x here, and that is the solution. Factorizing is your first step. Bloody hell, an hour. Right. As I said, pause it, flick back through things. If you've got any questions on anything I've done, email me. I will be checking my emails tonight, and I'll get back to you straight away. In terms of those of you who were not here today, shame on you, first of all. Hope you enjoyed your day off. Oh, here it is. We did our first 5 to start us off. It's the same as paper 2, guys. Make sure you're revising those formulas. There you've got them, your trig, all here. Histograms, cumulative, remember if it mentions cumulative frequency, you're adding the totals, and if you're drawing it, it ends up being that stretched S shape. Know your triangles, you're pretty good at that. Good chance you could get quadratic formula if you're factorizing, and that will be towards the back of the paper. This one I have not put in your formula sheet, so please make sure you know it. Hasn't come up yet. It did come up last year actually, but it's new to the curriculums. It's a nice question too, nice problems, so make sure you are familiar with these, okay? And you got a few more there. The circle, gradients, so if you see anything involving a line, good chance you might need to use the gradient. Again, that would be towards the back of the paper. And that is it. If I don't see you before tomorrow, good luck. Make sure you're doing your revision. It's calculator, so write down all your workings, etc, etc. One thing I will say, so again this is one that could come up if you've got a question like so. Simultaneous equation, one's a circle, the other is a line. Rearrange the linear and then substitute it back in here. You end up with a quadratic. Factorize it. The rest of it you're fine with. You've done loads of that, but that first step is the one that you keep mucking up on. Rearrange it, get x equals something or get y equals something, and substitute it back in. Okay. Like I said, good luck. Make sure don't do too much tonight. Do something at least. Don't be lazy about it, especially you, Jack Shepherd. And I'll see you guys in the morning. Thank you guys.